All right, how's it going, everyone? So in this video, I plan to build out a peer-to-peer messaging system or network using Node in Express.js. And if you don't know anything about like peer-to-peer networks, this will be a learning experience for all of us because I haven't actually dealt with peer-to-peer networks. But the idea is typically when you're trying to send a message from one person to the other, for example, if you're using like WebSockets or something, usually there is a centralized server and all the messages are going from your machine to some type of centralized server and then to your destination, right? So the plan in this video is actually to find out a way to get around the whole idea of a centralized server and instead have a cluster of servers that allow users to directly message and find each other without having to depend on a centralized server. So I think this will be a fun learning experience. And before we dive into the code, I do want to say that this video is sponsored by this diagramming tool I'm using called Eraser. Eraser has a lot of cool features in it where you can basically create system level cloud architecture and diagrams. You can create sequence diagrams. And you can also just freehand diagrams like I just showed you at the beginning of this video. So we're going to be using this tool to basically create as many different diagrams as we can to kind of architect the system and also kind of explain the different features that our peer-to-peer network will need to achieve. So I definitely recommend giving Eraser a try. Go to eraser.io. There's also a link to Eraser in the description below that I recommend you check out. So I want to start off with diagramming kind of like a higher level overview of what we're trying to build with this network. And like, again, I kind of showed you what we're trying to achieve, but how do you actually achieve that? So I'm gonna go down here and click a new file. And the nice thing about Eraser is that you have the ability to draw your different diagram stuff. Like I can draw circles here and I can type A for arrow and connect these together. It's very user-friendly and easy to kind of like jump around from all of these tooling. T for text, I can go ahead and type in here and type in like Bob. I can do a slash. I can add in some shapes or some icons like I did before. I could add in a server icon. And then on the left here, you can actually type in some notes that'll help you document and outline the diagram if you want to. So that was a quick little overview. We're going to be focusing on trying to do a high level overview of our peer-to-peer network, right? So let's just start off with a couple of things. I'm gonna go ahead and make an oval here, and I will make one over here. And let's just double click on this and say Bob, and double click on this one and say Sally. So the goal is we want to be able to send a message from Bob's machine directly to Sally's machine, right? Now, this is really easy to do if you know the IP address of Sally, but the issue is that you probably don't, right? You want to be able to just say, send a message to Sally, and you don't want to have to remember or call Sally and ask her for her IP address, right? So the cool thing about a peer-to-peer network is that typically you have a cluster of servers, and this cluster holds the information for like your entire network, right? It kind of has like a lookup table. And if you need to understand where Sally is located, what you'd actually do is you say, hey, I'm going to go ahead and talk to a node over here. And I'm going to say, hey, I need to figure out what is Sally's IP. Okay, that's like step one. And this node is going to basically check and say, hey, do I know where Sally is? Do I have Sally's information? And if it does not have Sally's information, it then needs to go and talk to its other nodes. And it has to kind of fan out and understand, okay, do any of the other nodes know where Sally is? So I'll say, what is Sally's IP? We'll go ahead and do that here. Now, at some point, you're going to reach a node that already knows where Sally is. Okay, so like when Sally's machine were to spin up, you know, I could name this task number 1. I could say like register Sally and her IP. Okay, I might even go back here and change this from a 1 to a 2, right? Let's just go ahead and call these seed nodes, or seed servers, I guess you could say. And we'll talk about like what a seed server is in just a bit, but we'll call these seed servers. But these servers are basically running the exact same code as the actual like code that you run on your actual laptop if you wanted to do this peer-to-peer network. Okay, so the idea is that when Sally first turns on her system, you would have to register her IP address to one of these seed servers, right? And these seed servers would probably be a hard-coded list of IPs that would live in the executable or live in the code base so that we know where to send our initial registration message to. So you kind of assume that, you know, these things have to always be running, or as many of these have to be running as possible. When Sally turns online, she's going to register and send out a message to one of these seed servers. It could be random. You could just keep going down the list until you successfully registered. But going back to over here, Bob again needs to figure out like what is Sally's IP address. So it's going to fan out from the seed server. These seed servers are going to talk to more seed servers until this reaches a server that knows where Sally's IP is, right? So this is actually going to return back some information here and say, I know Sally's IP. Okay, this one doesn't know. And technically, this one could fan out as well. And there's going to be some conditions that we'll have to add to our code base to prevent it from like infinitely fanning back and forth, because if you don't have some type of like mechanism, you'll have an infinite loop going on here where like the servers will just keep on going back and forth and like, hey, do you know Sally? No, I don't know Sally. And then I'll ask the same server it just came from. So we'll have to add some logic for that probably. But anyway, this server knows where Sally is. So it returns the IP address to this seed server. And at this point, this one will cache Sally's IP. Now, technically, we don't have to talk about caching yet, but like we're talking about performance systems, we'd probably want to cache the IP. Let's not even dive into that. But ultimately, this one should return Sally's IP to Bob. And then Bob should be able to directly connect or send a message to Sally. Okay, so that's like the ultimate goal that we're trying to figure out. And it looks kind of complicated, but once you kind of understand this fan out logic and like how you can talk to a node and that node can go and talk to other nodes to try to figure out where Sally is, do some type of like discovery mechanism, it's actually not too hard. So that is kind of like a high level overview of what we're trying to achieve. Now, what I like doing before I actually dive into code, I like to create something called a sequence diagram, which helps represent this exact same structure, but it kind of walks you through like the algorithm that your software would do. So you end up coming in just like implementing the thing verbatim. Okay, so I'm gonna go ahead and make a new diagram here. Let's just go back. I'll call this like high level overview. All right, so let's dive into the sequence diagram, right? So we're gonna try to represent how we can actually start coding up some code. I'm gonna go back here and I will make a new file and I will call this register a node, okay? So we need to figure out a way to basically, when Bob or Sally tries to spin up their messaging client, it needs to register with the cluster of servers, right? So how do we write a program that will register my computer with a cluster of seed servers? Question mark. That's what we're trying to solve here. And let's go ahead and try to diagram this out using a sequence diagram, right? So if you use this plus symbol here, you can actually go and say diagram as code, which is one of my favorite features of Eraser, but they do have a lot of other cool features. What this allows you to do is you can actually type in code, which will create this diagram for you, right? So we're going to go ahead and just type in Bob here, and we're going to go ahead and say like seed server. Actually, I'm going to start with Sally, and then let's just go ahead and delete the rest, okay? So when Sally first spins up her machine, what she wants to do is she wants to register with the seed server, right? And the cool thing about Eraser is you can actually add icons here. Like I could probably add a server icon. There we go. And that's step one, right? We want to register with the seed server. And before we even register with the seed server, I could probably make a note to myself. I could say Sally to Sally like this. And I want to say, find a random seed server, right? So there's probably some type of hard-coded list of seed servers that you can connect to. And we're just going to go ahead and just find a random one and then try to register. Okay, so that could be a post request at like some register endpoint. In fact, I'm just going to keep this really low level. This will be a post request to register on the seed server. And what the seed server is going to do is it's going to basically keep track. So it's going to track Sally's info. And that includes like IP address and I'll say IP and user. And that's basically so if anyone else were to try to ask this seed server where Sally is, it can then respond and say, hey, I know where Sally is. So now the next step is we want to basically allow Bob to figure out where does Sally like where she hosted at, right? What's her IP? So I'm gonna go ahead and make another thing here. I'll say Bob, and that's gonna be a line to the seed server. And again, this could connect to any of the seed servers. It doesn't have to connect to the same one. This could be like seed server 2 potentially, but we'll just go ahead and say seed server, and I will say look up Sally's info. And I'll say get at slash lookup. How about that? What the seed server has to end up doing is it's going to check. In fact, I'm going to change this from seed server to seed. I think it'll make it a little bit easier to diagram this stuff out. And what the seed server has to do is it basically needs to say, do I know where Sally is? Question mark. Do I know Sally's IP? And if I don't, I need to go and ask another seed server or another node in the cluster, where is Sally? Okay, so let's just go ahead and say like seed, and I'll say seed 2. Go ahead and zoom out just a little bit. This might be getting too small. I'm going to reorganize a little bit. So I want seed 1 and seed 2 to be kind of next to each other. And I'm going to go ahead and just add another server icon next to seed 2. So basically, Bob needs to figure out, hey, like, where's Sally? And then seed 2 doesn't know where Sally is, right? So I'm going to go ahead and just change this a little bit. Seed 2 is going to say, do I know where Sally is? It does not. So seed 2 needs to ask another node in the cluster, where is Sally? And it could also just do a get request on slash lookup. And then same idea, seed is going to make a request to seed and say, do I know where Sally is? And it does, right? In this case, this seed server knows where Sally is. So it's going to go ahead and just make a response like this. And it's going to send back Sally's info. And then when it gets to C2, C2 is just going to go ahead and send a message back to Bob like this and just send it Sally's info. Okay, and then finally, Bob can send a message directly to Sally, send message directly to IP. Okay, so a lot of stuff going on here. This is kind of the overview of like how the application is going to work. Let's just do one more walkthrough so we're all kind of on the same page. But I just want to exemplify, like, you know, software can get pretty complex, right? And adding these diagrams is the best way, in my opinion, to allow yourself and other developers on your team to truly grasp what needs to happen when you're architecting some type of feature or system. So again, Sally boots up her machine. It does a register to any of the seed servers. That seed server is going to track Sally's information, including their IP and user. And then later on, Bob's going to say, hey, I need to send a message to Sally. So I'm going to look up Sally's information. And then this seed 2 server says, well, I don't know where Sally is. So I'm going to go ahead and ask another node in the cluster, where is Sally? And it's going to do a get request to an at lookup endpoint. This one asks itself, hey, do I know where Sally is? And it does. So that's going to return with Sally's information to this seed server. And then this one will return a response with Sally's information directly to Bob. And then Bob will make a request to Sally directly and send a message. That is what we're going to try to implement. It should be pretty fun to do, hopefully, and it shouldn't be too hard. So again, we got 2 awesome diagrams that really demonstrate what we're trying to build out, and it just helps to plan before you just start jumping into the code. Let's actually go to the code. So I have a TypeScript project set up with the bare minimum. It just spins up an Express service on port 3000, and it just listens, right? It doesn't actually do anything. So we have to actually implement some of the logic, and we're going to be referring back to that diagram as we kind of run through this. So I'm going to say yarn dev, and that should spin up our server. And let's just verify. If I go to localhost 3000, do I get a response? And I do. I get, I mean, it's like a 404, but there's something there, right? So the first thing is I'm pretending like I'm Sally. When I boot up, I need to make a register request to one of these seed servers. Okay. So I'm going to say find a random seed server. Now in our case, we don't know where the seed servers are, right? So I'm just going to go ahead and pretend like we have a hard-coded list. And I'll say const seeds is equal to, and then we're just going to say HTTP localhost 4000. Let's just pretend localhost 4000 is where the seed server will live, or one of the seed servers lives. So again, following this diagram, when this Express service spins up, it needs to try to register via a post request to any of the seed servers. Let's just go down here, and I'm going to go ahead and just say like, on load, we'll make a function that's async like this, and we're just going to go ahead and call on load. You can call it initialize. Maybe we should call it initialize. I don't know. Again, this is like a live coding. I'm just showing you how I would solve this problem. I don't have any reference code like sitting on another monitor right now. We're going to figure this out together. So when this Express application first sets up, we need to basically get a random seed server. So let's say random seed server. And I would just call a method called get random seed server. Okay. I'm going to try to abstract away my code so it makes it easier to manage later on. But we're going to assume we have a method somewhere. I'll make a source directory, and I will just make a method called get random seed server. Okay, pretty straightforward. And we're going to go ahead and just say export function get random seed server, and we want to basically return one of the IPs from this array of things, right? So let's just go ahead and say return seeds. We can import that one, I believe, by just doing an auto import. I think I call it, oh, I didn't export it. Let's make sure we export that. And we're going to go ahead and say import seeds. And we'll say give us math.floor, math.random times seeds.length. Okay, so that should give us a random seed server. Does that make sense? Okay, let's just go ahead and import that one. And let's make sure this works when this thing initializes. So we should hopefully, if we console log this thing here, let's just go ahead and do a console log. So if I were to just go ahead and save the file and refresh, we'll see it prints out the seed server of localhost 4000. Pretty cool. And now let's move on. We kind of figured this one out. We're going to get a random seed server, and then we need to make a post request. So let's make another function here. I will say register with seed server.ts. We'll say export function register with seed server. And what this needs to take in is probably an IP. So we can say, this takes in a string. And we need to basically do some type of fetch request. I do have something called cross fetch already installed, so we're going to try using that. So I will say import fetch from cross fetch. And we can use this fetch function to basically make a request to that IP. In fact, I don't like the name IP. I'm going to call this URI because it's like an actual host name, right? So we're going to make a request that URI, and I'm going to say /register. Now, by default, when you do a fetch, it's going to do a GET request. And going back to the diagram, we did say we want to do a POST request. Okay, so we have to go back to our code and kind of specify a little bit of options here. We need to say the method is a POST, and then we need to say the body will be something. And then we'll say headers is content type application JSON. Now I'm going to add a return here so that we can actually get the promise of the results. And I'm going to tack on a then and just make sure that we get back the JSON data that comes back from the backend. I mean, if you've used fetch, you know how this stuff kind of works, right? Fetch is going to return you a promise, and then you have to tell it to get another promise by saying .json. It's kind of weird, but that's how it works. Okay, so the body, like, what do we actually need to send over to the seed server? We have to send some data over, and it turns out we need to send over like a user ID and an IP address. So let's just hard code this for right now. I can say json.stringify, and we could pass it a, not an IP. I'm going to say URI. I'm going to keep this as simple as possible. And we're going to say localhost 3000, and the user is going to be Sally. So now when this thing loads up, we actually want to try calling this method. And we're going to go ahead and just say like await register with seed server. We will say random seed server URI. I might rename this a little bit. And then what we also need to do is we need to send over the information, right? Well, in this case, we've hard coded it, but I think at a later point we'll come in with a .env or an environment variable and just basically make this dynamic. But let's just see if this works. If I were to auto import this file and save, I do believe this will throw an exception because we don't have any seed server running at port 4000, right? We also didn't add a register endpoint. So what I'm going to do is I'm going to go ahead and just make a new file here. We can call it routes. And inside of routes, I will say register.ts. Okay, so I'm going to go ahead and say export function register, and that's going to take in a rec and a res. And since we are using TypeScript, we should probably make sure we put the proper types here for request and response. Okay, I'll say response here, and I'm going to say import type. Okay, so we need to basically do something in this function. But before we do that, I'm going to go ahead and just say up here, I'll say app.post. And then if someone tries to hit a register endpoint, we will call that register route. Okay, so far, does that make sense? Like when we try to do a post request to /register, it's going to call function over here. And that function needs to do something. In our case, we need to keep track of the server that was just registered. Keep track of Sally. She just sent over some information. We got to track that somewhere. So what I would recommend doing is we could basically just have like a, I don't know, a file here called like servers, like that. We probably want to like just have like a centralized place that has some type of shared array reference or something. So for right now, I'll just say const export const servers is equal to a blank array. Technically, the seed servers could also be in here. I'll have to like rethink what I want to do with that. But what we're going to do is we're going to import servers. So we'll say like servers, import that, and we want to push something in, right? We want to push in the information of Sally and her URI. Okay, so how do we get the user and the URI? Well, we can basically get the payload. I'll say const user and URI, and we can say rec.body. And I believe the way Express works by default is it's going to parse the JSON request if I have Express.js as a middleware option here. So I think we should be good. When this register handler runs, we should be able to get user and URI out of the body. We're going to push those into the servers array. And then we're just going to say response, and we'll say send success. How about that? Now this is giving us a type error because we didn't actually type what array this is. So I'm going to go ahead and just put a type here. And I will call this a node. And we'll just go ahead and say export type node is equal to URI, which is a string, and user, which will be a string. All right, so what's this complaining about? Never is missing from the filing properties. Oh, I need to add a array here. All right, so now when I do a post request to this endpoint, it's going to push in an object into the servers array. Now, I mean, you might say that's bad that just import an array reference from another file, and it probably is. So maybe we should actually abstract this away with functions. I'll say like add server. In fact, I'll call this add node. And I will take in a node here, and this will be a node object. And what we need to do is we want to say if there's not already a node here, so I'll say that const is already added. We'll say servers.find, and we want to find a node where the user is equal to node.user. So basically loop through all the existing servers, and if we already have one for that user, then we don't want to add one already, right? We'll just go ahead and say return. If already is added, we can just return. Otherwise, we'll say servers.push node. That makes sense. So we have an array, we just keep pushing nodes to it if that user doesn't already exist. And we're not going to export servers anymore. We'll keep this as some type of internal private data structure so that we don't have to know about it. And then here we could just say add node, and we will just push in that information. All right, so let's take a step back. Does this work? Did we forget anything? Probably did. But now what we're going to do is we're going to add new terminal windows here. I'm going to add one for Sally. And then I'll add one for seed. Now in the seed thing, the issue is we need to spin this up with a different port. So I'll say port of 4000, and I'll say yarn dev. And that should spin up a server on port 4000. This actually failed. Why did this fail? Invalid JSON response at body. Okay. So this thing, the issue is that this server is trying to make a request to itself and register to itself. Okay. And I do think there is an issue with that logic where we say register with seed server. Let's go in here, and what we're going to do I'm going to make this content type capital T and capital C. I want to see if that's actually part of the issue. So I think this might actually be failing because like when we created our handler, let's see, where did I do that? Register handler. This should probably actually return some JSON, and I'll say like message success. I think that might be why it's crashing. There we go. So that's kind of fine now. So the issue with what we just did is that the seed server is basically registering to itself when it spins up. I don't know if we need to worry about that just yet. we have to kind of keep that in mind. There might be a lot of things that we didn't think about when we tried to diagram this out. But again, we're about right here. This is the amount of work that we added was we're tracking the URI and the username for Sally. Now, one thing I didn't like is that we hard-coded the URI and the user right here. So like when the node first comes online, it tries to register, and every time it's going to be Sally. So I might actually say process.env user, and then I'm going to say process.env.uri. Okay. Technically, I could just use port here to keep that a little bit simpler. Maybe we could just do that. Okay, just try to keep this as simple as possible. That's usually my recommendation when you're trying to build out code and figure stuff out, is just keep it as simple as possible. Make sure the proof of concept works, and then start refactoring code and make it cleaner and make it better. All right, so let's also add a little bit of logging, right? It's probably nice to know when someone added a node. So I'm gonna go ahead and just put a console log here, and I'm gonna go ahead and say, I'll say node.user registered at URI of node.uri. Okay, just get some more feedback. There's probably a better, more production ready way to do this, is like you could bring in a real logger with like log levels. Again, keep it simple. Okay, so it's saying web dev Cody registered at URI of this. Now, that's kind of weird. I don't know why web dev Cody printed out. I think this actually should be called like username maybe. And we're going to go ahead and say username is equal to seed for that one. We'll go ahead and stop this one. We'll say port is 3000 and username is Sally for that one. Let's see if this works. So let's try to saving a file. That should restart both of these, I believe. And it says that Sally registered at URI of localhost 3000 on the seed server, and that's pretty good. All right, now at this point, I might actually move my face up. Just go ahead and move my face up so I can actually see these terminal things down here before I start accidentally hiding them, because I think it's kind of important as we get more seed servers and nodes. So let's just verify. I think there's probably bugs in our system, but let's just move on. At this point, we need to now make basically the ability for someone to do a lookup on a seed server. Okay, so let's just go ahead and pretend like we don't have seed 2 yet. And we're going to add another endpoint where you can do a GET request on lookup, and we will call a lookup handler. So I'm going to go to routes. I will add one called lookup TS, export function lookup, like that. And we want to basically make sure that it has the same type of signature that we did over here. So let's just go ahead and copy that over. Make sure we auto import these things so that we don't get any type of TypeScript issues. And I also like adding a type in front of this stuff. And we'll say res.json message success for right now. Okay, so let's just verify, does this work? Now, I do think, okay, so there is like a race condition issue. The issue is that sometimes Sally is going to restart before the seed server, and we want to make sure that the seed server stays online when Sally's restarting. So I think we do have to add some type of like some fake delay, right? Because it's restarting both of these. NodeMon's restarting both of these at the same time. So what we're actually going to do is we're going to add a delay here. I'll say set timeout, and we only want to initialize after some type of delay has happened. So I'm going to go ahead and say like process, I'll say parsent process.env.delay. Otherwise, we will just do like, you know what, we could just delay 500 milliseconds, okay? So again, the whole point of that is we want to make sure all the servers have fully come online before you start trying to register with other servers, okay? It's a little thing that like you kind of have to add in when I'm doing this localhost stuff. Ultimately, like you wouldn't do this on a production system or a production network. Like you would assume there would be a seed server that's always online. But let's try that. So Sally registered at this, pretty cool. So again, what we're trying to do is like, can we do a lookup request on one of these machines? So let's just go to like localhost 3000 or 4000. I'll say /lookup, and we get back a message of success. Okay, so we know the endpoint works, but we actually need to add a little bit of logic to make this thing work. So I'm going to go to this lookup method, and we need to figure out a way to basically look through all the servers that we have and find the one that is the user that we're looking for. So what I would like to do is here, we could provide a user of Sally, I guess, as a query string. And we want that to give back the URI and the user. So let's just go ahead and say, what should we do? We're going to go ahead and just, let's go to the servers file here. And I'm going to go ahead and say export function get node by user. This will take in a username. I'll just call it user. That's fine. And then we're going to basically say return servers.find. We'll say server server.user is equal to user. So if it doesn't find that, then we're not going to get anything back. But again, we're just writing abstractions away so that this is kind of a private variable in JavaScript and it's not exported. So again, let's go back to the lookup file. First thing we want to do is I want to find server by user and call that method that we just created, right? And then I want to say rec.query.user. We're not going to worry about adding like error handling yet. We're just going to do like the most basic thing we could possibly do. But when we pass this, I think I actually need to say as string here because this will not be happy unless I do that. That should do a request and find the server, and we're just going to go ahead and return it. Okay, so let's just make sure this works. If I do lookup of Sally, do we get back Sally's information? There we go. So we get back Sally, URI is equal to this. So the lookup method works, but it's not fully done yet. But we're going to try to finish out this this diagram before we get into the more complicated things with adding two seed nodes and how do they like look up on each other. All right, so this works because we happen to hit a seed that had Sally's information. But if we were to spin up another seed server, so I'll just call this one seed 2, and I will say port is equal to 5000, and I'll say username is seed 2 yarn dev. So now we got 3 servers going now. And in fact, I should probably add that one to one of the seeds. I'll say like HTTP localhost 5000. Sorry, I think my head's cutting that off, by the way, but it says localhost 5000. So now we have 2 seed servers, and when Sally spins up, it should register on one of those. So like you can see here, it actually registered on the 5000 seed server. So if I were to hit localhost 4000 and try to ask for Sally, it is not going to return anything because it couldn't find Sally. It just returns null. In fact, I should probably have this return an actual like 404 error. Let's just go here and see what happens if you do this. This thing, it just returns nothing, right? Which is not good. We should probably actually have this thing say, if there is no server by user, then we're going to return res.status 404 and we'll send user not found. Okay. Otherwise, we will return the user that we found. So now let's try it again. User not found. We get a 404 message. But again, the issue is like we hit seed server 4000. It doesn't know where Sally is. So we have to implement this logic where it's going to basically say, do I know where Sally is? If not, I need to go look up Sally on another seed server. So how can we do that? Well, let's add another method here, like a little helper function that's going to say lookup user. I'll just call that a TS file. I'll say export function lookup user, and that's going to take in a username string. And the idea is that this thing needs to basically grab a random seed server and actually it needs to kind of go through all of its servers. And it needs to do the same thing. It needs to ask it, hey, do you know where this server is, right? So we're going to go ahead and grab this register method, and we're going to copy a lot of this code out. And we also want the cross fetch. So let's just go ahead and grab that too. So this method, I'm going to actually have it take in a user, and then it's also going to take in a URI of a potential server. Okay, and instead of saying register, it's going to do lookup, and it's going to find a user by that user ID. This will be a GET request, and this needs to basically do a request to the URI Actually, we don't even need a body here. We don't need any of this stuff. Let's just delete that. We can just do the default fetch, since that'll be a GET request. And I apologize. I think my head is hiding most of that stuff, but that's how it looks like. Basically, you pass in a user and a URI. It does a fetch request to that server, and it tries to look up based on the user. Now, I might add some additional logic here. I might say, like, if the response, if it's okay, then we will return response.json. Otherwise, we're going to go ahead and just throw a new error here saying like user not found. Just so that the callee of this function can know if like the user existed or not. This is just the way like fetch kind of works. Like it's going to return you a status code. If it was okay, then we know we have the information. Otherwise, we probably just need to throw an error. Okay, so let's go back to our main lookup function. Again, if this thing did not find a user, instead of just throwing user not found, what we should probably do is we should loop through every server that we know of and ask it. So I'm going to go ahead and just say for let server of get nodes. Actually, we don't have a method for that. So let's go to the server things. I'm going to go ahead and say export function get all servers. And maybe I should make it consistent. I'll just call it get nodes. Okay, and this is going to return a clone of servers so that we don't have like some type of, it'll return a new reference to the underlying server collection. Hopefully that's good enough. But let's go here. We're going to call that method like this. And then for every server that we get, we're going to try to do a lookup as well. So I'm going to go ahead and say like try, and then I will say lookup user, and I will say server.uri. And then we also want to do a, but then we also want to get the user, right? So the user was here. Go ahead and say like const user is equal to rec.query. Go ahead and call that. Now, the issue with this is that I believe this will recursively like traverse every node over and over again. And I do believe we're missing like all the seed servers. So like we have 2 seed servers here, but those aren't part of our actual list. So I think there's a couple things we need to do. The first thing I would like to do is I'm going to restructure this a little bit to be a list of nodes like that. And then I'm going to go ahead and set these to have URIs and then also users of seed. And then this one will be a URI, and this will be a user of seed 2. Okay, let's just go ahead and auto format that. Looks pretty good. So that'll kind of break our application a little bit because we were not expecting that thing to have that structure. And also what we should probably do is we should register every single seed server in that server's array. So let's just go ahead and say, we're going to load in the seeds here. So I'll say for let seed of seeds. And we're just going to say register with seed server on all those. Actually, we're going to say add node. And this thing will take in a seed. All right, this thing I think actually needs to be a URI. All right, let's see. We've made so many changes. This entire application is probably broken. So we got some more issues. Lookup user is expecting something else. Let's go here. It looks like we have an issue here. User. I think I just need to type this to have an actual like user in the query. And let's just look at this code real quick. So we have, I'm going to save. When I save a file, let's just double check that like stuff is getting registered correctly. So it's saying this, it's saying seed, when seed comes online, it's registering with Sally, which I guess that's fine. And then Sally is registering with seed 2. I guess I'm curious where seed 2 is getting registered. Did I not name this one correctly? Yarn dev seed 2. When this thing spins up online, it should. All right, so hopefully we're kind of doing okay. I know this code's just, I've been jumping around and this code's getting kind of crazy, but where are we right now? Let's go back to the diagram because sometimes these diagrams are the main thing that keep you on track. So we're trying to basically say if we haven't found Sally, then we need to go and look up on other nodes. And basically we just traverse all the nodes that we know of and try to keep on looking up. Okay, so here is the method that's doing the lookup. And we are basically saying, try to find the user in our current list of nodes using the user ID. Technically, this could just say user. Okay. And if we don't find one, then we need to loop through every single node that we know about and try to look up the user as well. So let's just go ahead and put a wait there. I'll put an async here. And if for whatever reason we've looped through all these and we cannot find any of the users, then we probably need to like just say, you know what, we can't find this user. I'm gonna go ahead and just put this code here. Otherwise, we're gonna track that user. So I'm gonna say let user is equal to, actually I'll call it found user to be more explicit with my naming. And we're gonna keep on trying to do this, right? At some point, we're either gonna find the user or we're gonna exhaust this list and we will not have found the user. But I'm gonna go ahead and, actually, this catch doesn't need to be here. I'm gonna go ahead and say if we found the user, otherwise we'll do this. I'll put this one down here. We did not find the user, we will throw back an error saying that we did not find the user. But if we did, let's just return res.json found user. Okay, now the catch, I don't know if we even care about the catch at this point. I think I could just put catch and do absolutely nothing. Like just do a void. Or do an empty object here. I don't know if we even need a catch, to be honest. We'll figure this out, right? Now, I do want to say that there is going to be an issue where I think I mentioned it in the other diagram where you're going to have a node that's going to request itself in like other nodes over and over and over again. And it's basically going to infinitely traverse your graph nonstop and basically eat up your sockets and like break your machine. So what we need to do is every time we try to look up a user, I think we want to like create a unique ID and attach that to the header of every request. And that ID could also be passed in as a header here. So I could say like request ID is equal to rec.headers, and I could say X. Actually, I think you just say get. I'll say rec.get. I'll say X request ID. And if this thing is not defined, I will just default it to UUID like this. I think I can import this. I have a package called UUID. If I look in package.json, I have a UUID here as a dependency. So I could import UUID before as UUID from UUID. Yeah, I don't know how to do this. I'll say, let's go to npm UUID and let's go look at this. All right, here's an example. There we go. And I'll just do that. So basically what I'm going to do is if we've already gotten this request ID, then like we could just return early. And then we also need to kind of forward that every time we look up a user. So I'm going to go ahead and pass it here. I know this code's getting a little bit hacky, but hopefully we'll figure this out. So this thing will take in a UUID, or sorry, it'll take in a request ID. I know that's blocking by my head, so let's just move that down here. And we want to attach a header here. I'll just go ahead and say like headers, and we'll say X request ID. And I'll just go ahead and pass that. So the idea, every time you do a lookup, it's either you don't provide an ID or you do provide an ID. And if the server happens to find an ID that I already saw in the past, then it could just return early and not like infinitely loop forever. So I'm gonna go ahead and say like const scene IDs is equal to new set. We'll do that. And every time we make an ID or we find one from the headers, we'll just go ahead and add this here. So I'll just say request ID. And I'm just going to go ahead and say like if we have seen this ID, so ID scene IDs.has request ID. Go ahead and do it up here. If we've already seen this ID, we just need to return early and just say, hey, like, you know, there's no user. We already know, we've checked, there's no user. All right. All right, so the moment of truth, what we're going to do is we're going to go ahead and just try to look up where Sally might be. And I did notice that it's printing out like, I have an overload going on here. This is not good. So I'm going to go ahead and say like, I'm going to rename this one to existing node so that we don't have this naming overload. I just noticed that there's like a giant bug in our code base. So seed 1 and 2 registered on Sally. Seed 1 and 2 registered on seed. Okay, so these are just like, okay, so it looks like Sally got registered on seed 2. All right, so let's try to go to seed 1, which I believe is 4,000. I'm going to try to do a lookup on Sally and see what happens. This might crash my entire backend, but let's try it. We'll do a lookup on Sally. We got back a 404. It says user not found. So let's go back to the code base and try to figure out why did it not find Sally, because Sally should have been found in the network, right? So let's go back to lookup here. And we're going to try to just add some console logs to make sure. Let's just double check our code real quick, and then we'll add some console logs. So basically, you make a request to lookup. We try to see the user that you provided in the query, which we did user of Sally. And then we look to see if we have a server by that user already. Look at this code. This one basically loops through your servers and it finds one based on the provided user ID, the username. And if we don't find one, we're going to go ahead and loop over all the servers that we know of. We're going to pass in that request ID, and we should be able to get back some information. So I'm going to go ahead and just put a console log here, and I will say looking up. I'll say user not found on this node, checking, and then we'll do like server.uri. I can call it user. How about that? All right, let's try it again. So Sally registered on 4,000 this time. Let's actually try 4,000 and see what happens. So it did find it. If you hit 4,000 directly, you do get a response back. But if you were to go to the other seed node, this is saying user not found. So let's go back to seed 2, saying user not found on this node, checking seed. So then seed should have got a request. And it should have basically printed out here a request for user was made. And then I will say, print this out. All right, Sally registered on seed 1. So I'm going to go ahead and go back to seed 2. And we're going to refresh the page and see what happens. Okay, so seed 2 got the request. It cannot find Sally. So then seed 2 should have hopefully made some requests to seed 1. Which it didn't get any requests. So I'm thinking maybe there's an issue with I'm doing requests to the same thing over and over again. So let's actually put the console log here. And the only reason I'm not using a debugger is because, like, you know what? I don't even know why I'm not using a debugger. All right, Sally's registered on seed 1, not seed 2. So let's just go ahead and do a refresh here. That makes a request to Sally/lookup. I think I had the URIs in the, yeah, I had these swapped. This is why I don't like doing ordered parameters in my code base. I don't know why I'm doing it in this particular example, but I swapped user in the URI. All right, so Sally registered at this seed. Let's go back. I'm going to go ahead and just look up here. And we do get back Sally here. Let's try it on 5 as well. Now let's try it for Bob. User not found. User not found. Okay, I think we might have actually done it. I'm sure there's a ton of bugs in our code base, but I think we might have done it. All right, let's go back to our diagram because I think we're almost there. Okay, so we kind of went down here. This returns Sally's info. This returns Sally's info. So now what we want to do is we want to basically be able to send a message from Bob directly to Sally. So let's add yet another node for Bob, and we probably want to add another endpoint as well. Let me close out some of these things because it's actually eating up my CPU as I'm recording. But if we were to add another route called message, and we'll go to server here, and I will say, I'm sorry, we'll go down to index. I want to add another endpoint. I'm going to say app.post to message. That's going to call the message endpoint, which I don't think we named yet. So let's go here. I'll say export function message. We're going to copy the signature for the other method so that we don't have to repeat ourselves too often. Okay. Now, what does this one need to do? Basically, it needs to first do a lookup and say, hey, I need to find where a user is. So we're going to pretend like this takes a post request. This takes a from user, it takes a to user, and it takes a message. In fact, I might rename this the send. I'm gonna call this send. And this, that, I'm gonna call this send. Okay, so the idea is you can send a message by hitting this endpoint, and it's going to first look up the user. I'll say user node, and we can basically just say lookup user here, which I believe we already have a lookup method, right? We already do have a lookup user method. I'm going to see if we can kind of repurpose some of this stuff, right? So if we look at this handler we wrote, is there something that we can repurpose to basically use the URI that we currently have? I think we could potentially just like call this. Yeah, I'll just do this. And we're going to call lookup user, and we're going to make this async so we can do an await on it. And request ID, I guess we should be proper and make like a UUID here. So I'm going to go up here and add, I'll pull this in, and then I'll call it. And then we want to basically try to look up where the to is, right? And then we're going to use process.env.uri. That should be defined. Okay, kind of hacky, but hey. Now, what we're going to do is we are going to basically say if we got a user, I might actually have to wrap this in a try catch in this particular example here. I might have to say try, and then I'm going to say catch. And then if we found the user, I'm going to go ahead and just say we want to, yeah, we're going to have to do some stuff with the find user. Otherwise, I mean, so if we don't find the user, like we should probably just say return response JSON status 44. And then we'll just say the same thing, user not found, which I think I can say send user not found, right? But if we do find the user, we're going to make another utility method called like send message. And what this needs to do is basically very similar to like the lookup user. We're going to make a fetch request, but we're going to call it send message that takes in a to user, takes in a message, and probably needs to take in a URI, right? So let's just go ahead and say we're going to send a message to that URI, and it's going to be a post request. So let's make sure that we have like method of post. And then we also want to say body is JSON stringify. And we're going to go ahead and put, I think we wanted to say the user, and we'll say message. How about that? And then for headers, we can say content type application JSON, I believe. Okay. Yeah, so, you know, we won't even worry about this. We'll just go ahead and just do the fetch request, do the post request. And we want to make sure we call this here. I'll just call send, and we want to basically send it to the to user. We want to send it to, what's the URI? Actually, what's the message? We want to get the message, and we want to say found user URI. There's no typing here, so I might actually say like as node. I might have to actually say promise dot of node. Let's see. I just want to add some typing here. Like I should be able to see promise a node. Yep. Okay. So found user dot URI, and we're going to send that message over. And hopefully that all works. Technically, we don't even need a from. Let's just get rid of that for right now. All right, so we added a lot. I think we also just need one more route, like for accepting messages. So if someone wants to send you a message directly, we need an endpoint to basically print that out to the console, right? So I'm gonna go ahead and copy over some code here, and I will say message, and we're just gonna go ahead and say console.log rec.body .message, and yeah, I think that should be okay. Let's just go ahead and try that, and then I'm gonna say res.json message success. Okay, so anyone can hit this node and send in a message, and all this does is console log it. Okay, so now we also need to register this thing here. I'll say app.post/message, and we're going to go ahead and just bring in that message handler. All right, let's make sure this works. I'm going to go ahead and just type in message here. In fact, I'll have to use like Postman or something. So let's go to Thunder Client. I will make a request to that endpoint. I'm going to go ahead and do a JSON request, and I will say message of hello world. I think that's all you really need for that. If I do it, let's see. Okay, I don't have any nodes running, so I think if I were to try it again, but I do believe there's an error here. Let's save the file and see what happens. It's crashing on something. Oh, I can't register it on a seed node. So let's just go ahead and start up one of our seed servers here. And then I'm going to save. Okay, so now it's working. We're registered. Let's go back to Thunder Client. I'm going to do a request to this endpoint. I need to make sure it's a post request. And I will send it. And notice that it prints out hello world down here. So this node actually got a message. Unfortunately, we don't know who the message came from. It's kind of like random, right? Maybe we should send that over in the payload. Like we could say like from, and then we could say Bob or something. Just so that we have more information about like who sent the actual message. So let's go back over to send message. And we're going to make sure that we send over a from. I'm going to go ahead and do this. And we'll say from user. You know, I'm going to call this from. There. And what we want to do is on the send endpoint, we want to basically, actually the 2 here is wrong. The 2 is used for looking up the user. This needs to be process.env.username so that we know who sent the message. And then when we get the console log, why is this failing? You know, I'm also going to do rec.body.from and then also print out the message. Maybe I can do some string interpolation here. So I could say like this, and then this person sent this message. All right, I went ahead and just spun up seed 1 and seed 2 in Sally. Let's try this out. I'm going to send a message to Sally. Make sure it prints out Bob said hello world. Okay. And technically, I should be able to send a message to anybody else. Okay, let's try the send endpoint. I don't think we even tested that out. So if we wanted to do a send request, and I wanted to say I need to send a message that says hello world, what does our send endpoint require again? It requires a to, and it requires a message. Let's go here. I'm going to go ahead and say to, and I want to say Bob. The message says hello world. So the idea is if I were to spin up a new node for Bob, name this the Bob. I'll say port is 6000. Username is Bob, our dev. That should register with one of the seed nodes, which I believe, let's look through here and see which one. It registered with seed number 1. All right, so the idea is like I want to be able to have the Bob node send a message to Sally. So I'm going to go ahead and just rename this to Sally. And if everything is successful, we should see something print out over here on Sally's terminal. I'm going to go ahead and clear that. And I'm gonna go ahead and click send and see what happens. So it tried to look up undefined user. So I think I forgot to add a URI here. So let's just go ahead and add that URI. You know, I think there's something else that we forgot to do. I'm assuming that there's yeah, we don't have a process env URI. I don't know why I put that. This should actually be localhost process.env.port. All right, let's just go ahead and spin up Bob again and see what happens. And again, the idea is I want to send a message from Bob's node and to send it to Sally. All right, so I'm gonna go ahead and say, send a post request to localhost 6000. Make sure the message hello world goes to Sally. I'll click send. And so this is getting pretty complicated. I'm not gonna lie. I'm gonna go ahead and click save and see what happens. I want to make sure that Bob is actually registered somewhere. So Sally got registered with seed 2. Bob was registered at seed 1. I should be able to all right, there's definitely a bug with our code. Let's try to figure it out. So we're doing a 2 and a message. We're sending 2 and message. We're doing a post request to this endpoint. That seems correct. We're looking up the user. We should have gotten back a found user here. So let's try to figure out. We're trying to send from the message in the URI. We're saying URI / the message. The found user URI. So are we even getting back a found user here? Let's just go ahead and print this out real quick, just to see if we're like doing something wrong. I think the issue is I'm trying to do a lookup on my own node, but why would this ever know how to find this user? You know what I mean? All right, so when I do a send, this does a lookup user, which basically just does another GET request to itself and hits the lookup endpoint and passes the user we're trying to find. And then it passes a UUID v4. This calls this method, and that tries to look up the user from the query string that we passed in. And then it should add that request ID to the seed IDs, and then it should say a request for user. So if we look at Bob, it says a request for user Sally was made undefined. So it doesn't have, Bob doesn't have Sally, right? That makes sense. And then it's going to go and loop through all the seed servers. And it's going to basically call the same thing. So it's going to do a lookup for Sally. It's going to pass in that request ID. And then one of those should hopefully have Sally. This one has a request for user Sally was made, which is here. Server by user. And if there is a server by user, we just return it here. So res.json send server by user. So seed 2 should have returned back the request. I found a little issue where I was doing a GET request to my own node, but really like what we could do is just do a GET request to look up from one of the seed servers, because hopefully those would know the user we're trying to find. So instead of doing my own localhost :port, I decided to just say get a random seed server and make the lookup to that. And it seems like that fixed whatever issue I was seeing. Again, this code is, it's obviously the system is complex, right? It doesn't seem like it'd be that hard, but it's kind of hard for me at least to wrap my head around. And debugging this stuff can get very, very difficult when you have 4 different services that are all trying to communicate and pass messages from each other. But let's just try this out. So again, I'm just going to try to do a send request to Bob, and I want to say, hey, I want to send a message to Sally. And if I click send and go over to Sally, notice that it printed out Bob of Hello World, right? So now I can just send whatever message I want. And this obviously doesn't seem too cool, right? This doesn't seem too groundbreaking, But the interesting idea of it all is that Bob and Sally had no idea how to find each other, right? And they went through some type of distributed network to figure out where the IP or the URI was for each other, and they could send messages. And I think like as you add more nodes and make the system more distributed, I think this whole idea of like a distributed system and peer-to-peer networking is pretty cool. Now, obviously, there's a lot of stuff that we would have to address if this was going to be used in production, right? First of all, we don't have any type of peer-to-peer encryption going on. So you want to encrypt every message that's going from Bob to Sally. All right, so we just kind of demoed that we can send a message directly from Sally and that gets printed out to our console, okay? So this diagram, in my opinion, really helped me understand like what we needed to do, and I can kind of walk through the sequence step by step and implement the logic necessary to build a more complex type of system. I don't know if you thought this was pretty complex, but I got tripped up quite a lot in various points. So yeah, let's go back to the high level overview because again, this is what we were trying to do. And hopefully like walking through the code, it kind of made sense. So again, when Sally starts up, they register with the seed server. And then later on, Bob says, hey, I need to look up Sally's IP address. That traverses this system and tries to keep on traversing the nodes until it finds one that has Sally's IP address. And then it returns that back. And finally, we send a message over. So again, there's like more things we could add to this code base to make it more performant. We could add some type of caching. So for example, every time you do a lookup, if you find a user here, what you could potentially do is you could just add it to your list of seed nodes. Like I think you could literally just say add node here, and I can say found user, and that would mean that you have caching kind of built in. Let's try it out and see what happens. Okay, I'm gonna go ahead and just save. Okay, so now we have like fresh servers. I'm gonna go ahead and clear my consoles real quick. And I'm gonna do that same request. So I'm gonna say, I'm gonna send a message from Bob to Sally, and that has to kind of traverse the network. So that actually caused like a infinite loop to happen where like both of my nodes were just continuously sending messages to each other. So maybe that's not the solution, but I do believe there, if I spent more time trying to investigate this code and really make sure I understood it better, you could potentially cache the users that you find and put them in that server list, right? All right. So I think that I actually have a bug here where the fact that I'm adding this catch is actually making this become undefined in some cases, even though the user was found. I think what I actually want to do is I probably want to do this instead of actually like suppressing that catch. Probably want to do this and just set it like I'll just have a blank catch here. I have a hunch that's my issue. Yeah, so I literally like went off camera for like 10-15 minutes just looking through my code. And that's the issue. I had that strange catch thing, which was suppressing the actual found user, and that was causing some bugs. So again, like if you wanted to cache a found user already, I'm pretty sure you could just do this. Just add that user you found to your list of servers. And then like any future request won't have to traverse your entire network. Let's just try this out real quick, and then I'll probably wrap up this video. So let's do a first request from Bob and Sally, and you will see that that traverses quite a bit of nodes before it finds Sally. It has to go from Bob, that hits seed 2, and that hits seed 1, and then you get back the information. But I think if you did it again, since we're trying to cache that information, I think Bob will actually not hit anybody. Or maybe it hits less, right? It seems like it just made a request to Sally, and that's about it. Now, I think if we actually were to hit the lookup endpoint from the Bob node itself, it would even do less requests. But maybe that I'll leave for another day when I have more mental capacity to really understand what's going on here. But I'm going to go ahead and commit what I have. I'll just go ahead and commit this all, and I'll say working on the initial B2B network. Now, you're welcome to go through this code and do whatever you want with it. I I guarantee you there's bugs. I guarantee you there's things I can improve on. But I think this is a pretty interesting starting location if you wanted to try to create your own peer-to-peer network and just try to understand like how you can set up these nodes and have them all talking to each other. I'm gonna go ahead and just close out of some of these. All right, so some final remarks. Again, this video was sponsored by Eraser. So if you do like the diagramming that I provided in this video, I definitely recommend go check them out. Create an account. You can start creating some diagrams for free. Definitely recommend go check it out. They have a free plan where you can have 5 workspaces and unlimited collaborators. And of course, they have a team plan if you find their service useful, which I think you will, and you want to actually collaborate with a team and have your diagrams shared amongst different team members. If you enjoyed watching this video, be sure to give me a thumbs up, like, comment, subscribe. And like always, I have a Discord channel that you're welcome to join if you want to talk to me directly or just find a place to hang out with some other developers. The link will be in the description below, along with the Eraser link that I will put in the description of this video and probably in a pinned comment. Anyway, I hope you guys learned something watching me struggle how to build this little network. Have a good day and happy coding.